Good morning class. Today we discuss compressibility factor. Student, the deviation from ideal gas behavior can be measured in terms of compressibility factor, which is the ratio of product of PV and nRT. Now let us discuss once again compressibility factor. Compressibility factor is indicated by letter Z. It is the ratio of the product of pressure, volume and nRT. If we introduce letter Z in the ideal gas, it should be applicable for real gases. Here Z is the compressibility factor, which is the ratio of product PV and nRT. It should be noted if the value of Z less than 1, it indicates negative deviation, that is gases are more compressible. It means gases are more compressible. Gases are more compressible. If the value of Z is equal to 1, it indicates ideal gas. It is an hypothetical gas. If the value of Z greater than 1, it indicates positive deviation. Positive deviation means gases are less compressible. Gases are less compressible. If we plot a graph between the compressibility factor and the pressure, we will obtain a straight line like this manner, which is parallel to pressure axis. It indicates ideal gas, while the negative deviation gas is shown by this manner, and this is the positive deviation gas. Hydrogen and helium is there, positive deviation. Carbon monoxide and methane show negative deviation. That means these gases are highly compressible. So I repeat once again, compressibility factor may be defined as a ratio of product of PV and nRT. If we introduce Z in ideal gas equation, then it is applicable for real gases. Now if Z is less than 1, it shows negative deviation, means gases are more compressible. Example, carbon monoxide and methane. If Z is 1, then it indicates ideal gas. If Z greater than 1, it shows positive deviation. That means the gases are less compressible. Now let us discuss Boyle's point or Boyle's temperature. The temperature at which the real gases obey ideal gas law over appreciable range of pressure. I repeat, the temperature at which real gases obey ideal gas law over appreciable range of pressure is called Boyle's point or Boyle's temperature. Now let us discuss equation of state for real gases. I repeat once again. Now let us discuss equation of state for real gases. Equation of state for real gases, that is Vanderwaal equation. According to Vanderwaal equation, P plus A n square upon V square, V minus NB is equals to nRT. Vanderwaal equation is P plus A n square upon V square, V minus NB is equals to nRT. Here small a and small b are Vanderwaal parameters. Here small a indicate force of attraction between the molecule in a gas, and B is the co-volume or excluded volume. Now let us discuss critical temperature. Student, the temperature above which gas cannot be liquefied, however high pressure may be applied over it. I repeat again, the temperature above which gas cannot be liquefied, however high pressure may be applied over it, is called critical temperature. For example, critical temperature for carbon dioxide is 30.98 degree centigrade at 73.9 atm pressure. I repeat again once again. Critical temperature is the temperature above which gas cannot be liquefied, however high pressure may be applied over it. For example, the critical temperature for carbon dioxide is 30.98 degrees centigrade at 73.9 atm pressure. Now, student, it should be noted, weaker the intermolecular forces. Student, weaker the intermolecular forces means difficult to liquefy the gas, hence lower will be the critical temperature. One most important thing is gas below its critical temperature is called vapor. For example, CO2 below its critical temperature is said to be CO2 vapor. I repeat again, gas below its critical temperature is called vapor. For example, CO2 below its critical temperature is called CO2 vapor. Now, let us discuss vapor pressure. The pressure exerted by vapor at equilibrium is said to be its vapor pressure. I repeat again, the pressure exerted by vapors at equilibrium is said to be its vapor pressure. More the vapor pressure of liquid, lower will be its boiling point and vice versa. Now, let us define the boiling point. Boiling point of a liquid may be defined as the temperature at which the vapor pressure of liquid is equal to the atmospheric pressure. For example, the boiling point of water is 100 degrees centigrade. That means at 100 degrees centigrade, the vapor pressure of water is equal to the atmospheric pressure. Now, there are two type of boiling point is there. The first one is the normal boiling point. Student, the boiling point of a liquid at 1 atm pressure, I repeat it again, the boiling point of liquid at 1 atm pressure is said to be its normal boiling point. For example, water has normal boiling point 100 degrees centigrade, while the boiling point of liquid at 1 bar pressure. While the boiling point of a liquid at 1 bar pressure is said to be standard boiling point. For example, standard boiling point of water is 99.6 degree centigrade. I repeat again, the boiling point of liquid at 1 atm pressure is said to be normal boiling point, while the boiling point of liquid at 1 bar pressure is said to be standard boiling point. Now, let us discuss surface tension. Student, every liquid has a tendency to minimize its surface area. I repeat again, every liquid has a tendency to minimize its surface area. This property of liquid is said to be surface tension, or we can define surface tension as, surface tension is defined as the force acting at right angle to the surface along 1 centimeter length of surface. Its unit is Newton per meter. I repeat again, surface tension is defined as the force acting at right angle to the surface along 1 centimeter length of the surface. Its unit is Newton per meter. It should be noted, raindrops are spherical in shape because sphere has minimum surface area. Also, capillary action is also due to surface tension. The magnitude of surface tension of liquid depend on attractive force between molecules. When the attractive force are larger, the surface tension is larger. It should be noted, surface tension decreases with rise of temperature because the intermolecular forces decreases. On the other hand, we can say the surface tension will solely depend on attractive force between or among molecules. Now, last topic of this chapter is viscosity. Viscosity is defined as the resistance to flow which arises due to internal friction between the layer of fluid as they slip past with one another while liquid flow. The SI unit of viscosity is Newton second per meter square. I repeat again, viscosity is defined as the measure of resistance to flow which arises due to the internal friction between the layer of liquid as they slip past with one another while liquid flow. Its SI unit is Newton second per meter square. It should be noted, viscosity of liquid decreases with rise of temperature. Also, boiling point of a liquid is nearly 2/3 of its critical temperature. It should be noted. Boiling point of a liquid is approximate 2 by 3 of its critical temperature.